Hello everyone, welcome back to Kapil Joshi tutorials. In today's video, again we are going to understand one of the most important concept in SVM, that is support vector, decision boundary, and maximum margin hyperplane. And you will get a maximum benefit from this topic. Many students find these concepts confusing because of the mathematical terminology. So today we will understand them using a very simple and interesting cricket example. Let's get started. Suppose we want to classify cricket batsmen into two categories. Green plus, that is high performance batsman. Red plus, that is low performing batsman. Now we need some features to classify these players. So let's consider two features. X1 is equal to batting average and X2 is equal to strike rate. So every batsman can be represented as a point on our graph based on these two values. For example, a batsman with a higher batting average and high strike rate may appear in the green region. A batsman with a relatively lower average and strike rate may appear in the red region. Now, our question is, how can SVM separate these two groups? So, we will discuss decision boundary. Look at the blue line in the diagram. This line represents the maximum margin hyperplane, which we can also understand as the decision boundary in this classification problem. Its purpose is to separate the two classes. But here is the important point. SVM does not simply select any line that separates the two classes. Instead, it tries to find the best separating boundary that maximizes the margin between the two classes. Think about it like a cricket pitch. Imagine that the red players are standing on one side and the green players are standing on the other side. We want to place a boundary between them. If that boundary is too close to one group, even a small change in a player's statistics could cause a wrong classification. Therefore, SVM tries to keep the boundary as far as possible from both groups. So this is called the maximum margin principle. Now, what are support vectors? Now let us focus on the most important point in the diagram. These points are called support vectors, plus green sign and plus red sign. Support vectors are the training data points that lie closest to the decision boundary. Let's return to our cricket example. Suppose most best batsmen are clearly either high performing or low performing. Some players, however, have statistics that are very close to the classification boundary. For example, one batsman may have a batting average and strike rate that make it difficult to decide whether he belongs to high performing or low performing category. So these borderlines players are similar to the support vector in SVM. So they are extremely important because they help determine the position of the optimal decision boundary. That's why they are called support vector. Now, positive and negative hyperplanes. What are these terms? Now look at the diagram again. You can see three important lines. The lines in the middle is the maximum margin hyperplane. On either side of this boundary, we have two parallel hyperplanes, positive hyperplanes and negative hyperplanes. The distance between these two hyperplanes represents the margin. The support vector lie on a closest to the particular margin boundaries or similarly to these margin boundaries. So remember, larger margin, that is the better separation. And SVM tries to find the decision boundary that provides the maximum possible margin. So classifying a new batsman. Now let's take a new example. Suppose a batsman has batting average 48, a strike rate 142, and we plot this batsman on our graph using these two features. So SVM now checks the position of these new points relatively or relative to the decision boundary. If the point lies on the green side, the model predicts high performing batsman. If it lies on the red side, the model predicts low performing batsman. So the decision learned during training is used to classify new unseen data. This is the important mathematical connection. So there is one more important point. Students sometimes use the term decision vector when discussing this diagram. However, support vector is the standard SVM terminology. The SVM decision function can be represented as fx is equal to wtx plus b, as we already discussed in previous video, where w is the weight vector and b is the bias. And now we can talk about x represent the input feature. The sign of the decision function determines which side of the decision boundary the new data points belong to. The classification decision is generally determined mathematically by weight vector and bias, while the support vector are the critical training points that determine optimal separating hyperplane. So just quickly we'll revise this complete video. X1 is your batting average, X2 is the strike rate, green points is high performing batsman, red points is low performing batsman, and blue line is generally maximum margin hyperplane or decision boundary. And what are the closest point? Closest points are support vector. Distance between the margin and boundaries, it's called particular margin. And the main objective of SVM is to find a decision boundary that separates the classes while maximizing the margin. So this is how support vectors, maximum margin and decision boundary work in SVM. If you found this cricket based explanation useful, so like the video, subscribe to my channel Kapil Joshi tutorial, and stay connected for more easy to understand machine learning concepts. Thank you for watching and see you in next video. Bye bye.